Welcome to this session on Java input, output, and file handling. This presentation will take you through the fundamentals and advanced of input and output in Java, focusing primarily on how to manage files effectively. Java's input and output capabilities are robust and designed to handle a wide variety of input and output sources like files, memory, network sockets, and even keyboard input. Those features are crucial for building real world applications that interact with the users or systems through data. Throughout this session, we will explore the difference between byte and character streams and how Java represents those streams using various classes. We will look into how files are created, read, and written using both byte and character based approaches. Additionally, we will cover buffer streams, which performance, and also into serialization, a process of converting objects into a stream of bytes. To ensure clarity and retention, we will include multiple practical examples and code to demonstrate the discussed concepts. By the end of this session, you should be comfortable with the major classes involved in Java input and output and understand how to use them effectively. In this session, we will cover several essential topics that form the core of Java input and output and file handling. The aim is to provide both theoretical understanding and practical skills so that you can apply those concepts directly in your Java project. Let's walk through the agenda. First one, Java input and output basics. We will start with a high level overview of what input and output mean in the Java programming context. Second one, byte versus character streams. Understanding the difference between those two types of data streams is fundamental. We will look into the core classes and that supports each and the types of data they are best suited for. Third one, stream classes. This includes an overview of input stream, output stream, reader, and write classes, along with their common subclasses. Each of those plays a specific role of input and output operations. Fourth one, file handling. We will deep into the file class and how Java enables us to create, read, write, and delete files or directories. Fifth one, buffer streams. Performance is key, especially when dealing with large files. We will see how buffered streams improve input output efficiently. Sixth one, serialization. Learn how to convert Java objects into byte streams and vice versa, which is crucial for saving and loading object states. Seventh one, practical example. Finally, we will wrap up some real world coding examples to reinforce everything we have learned. Introduction to Java input and output. Java IO stands for Java input and output, which deals with the transfer of data to and from external sources such as files, networks, memory, or devices. As its core, Java input and output enables applications to read data and produce data in a structured and efficient manner. There are two major packages that support IO operations. Java IO, the traditional and widely used package that provides the core classes for stream-based IO. Java NIO, introduced in Java 1.4. This stands for New Input and Output and supports more scalable, buffer-oriented, non-blocking input and output. Java treats data as a flow of streams. Those streams are abstract representations of input and output sources, and they help in isolating the details of actual data sources from the programmer. This abstraction simplifies input and output operations significantly. For example, whether you are reading data from a file or from a network socket, Java allows you to use similar patterns of stream based programming. Why do we need Java input and output? Well, almost every program interacts with its environment, reading user input, saving results to files, transferring data over the network. Java input and output applications make those interactions possible. In this presentation, your focus will primarily be on java.io as it forms the basis of file handling and stream management in Java. Later, you may explore Java NIO for more advanced use cases such as channel based input and output or memory mapped files. What is a stream? In Java, a stream is a logical flow of data. Think of it as a pipeline through which data travels from a source to a destination. Java uses this stream based approach to standardize data input and output operations, regardless of the actual device or file involved. There are two main types of streams in Java. First one, byte streams. They are built on the input stream and output stream classes. Byte streams are suitable for reading and writing all types of binary files like images, videos, PDFs, etc. Second one, character streams. Those are designed for handling textual data. They are built on the reader and writer classes and are ideal when working with text files, XML and similar formats. Each stream can be unidirectionally, either it reads data or writes data. Java does not have built-in bidirectional streams. Instead, you use separate input and output streams. Java also provides the ability to chain multiple streams together using wrappers. This allows you to combine features such as using buffer reader with a file reader to improve performance when reading large files. Understanding streams it is critical for mastering Java input and output. They form the foundation for almost all input and output operations. Byte streams overview. Byte streams are designed for handling raw binary data. They are ideal when working with files that don't contain human readable characters such as audio files, image files, or serialized object files. In Java, the byte stream classes are based on two abstract classes: input stream for reading binary data, output stream for writing binary data. Those abstract classes have several implementations for different sources or destinations. File input stream and file output stream for file based byte input and output. Buffer input stream and buffer output stream for buffer reading or writing, which improves performance by minimizing disk access. Data input stream and data output stream allows reading and writing of Java primitive types in a machine independent way. While byte streams are powerful, they don't interrupt the content. So, if you are working with the text data, it's better to use character streams, which we'll explore next. Character streams are designed specially for handling textual data in Java. While byte streams read and write data in 8-bit bytes, character streams use 16-bit Unicode, allowing support for international characters and human readable text. Character streams are built on two key abstract classes: reader for reading character data, writer for writing character data. Those classes are the character based counterparts to input stream and output stream. They simplify working with the text by automatically handling character encoding and decoding. This is particularly important when working with different languages or especially characters where encoding like UTF-8 or UTF-16 plays a critical role. Some commonly used classes: file reader and file writer directly read and write character data from two files. Buffer reader and buffer writer improve efficiency by buffering input and output. Print writer offers convenient methods like print, println for formatted outputs. Character streams are especially useful when working with configuration files, XML documents, or source code files, where text formatting and readability are crucial. The key benefit here is that character streams handle character encoding automatically, sparing the programmer from manual dealing with complex byte to character conversions. Input stream class. The input stream class is the abstract superclass for all byte input streams in Java. It defines the fundamental methods that the all byte input streams must support. Since it's abstract, you never use input stream directly. Instead, you use one of its subclasses such as file input stream, buffer input stream, or data input stream. Key methods provided by input stream include int read reads the next byte of data and returns it an integer. Return 1 if the end of the stream is reached. Wide close closes the stream to release system resources. This example reads bytes from a binary file and prints them as integer. In real applications, you might convert those bytes into useful data types like images, audios, or custom objects. The input stream class is the foundation of all input byte operations in Java, and understanding how it works helps you use its subclasses more effectively. When performance becomes an issue, you will likely replace this with a buffer input stream, but the method signatures remains larger consistent. Output stream is the abstract superclass for all classes that write binary data in Java. Just like input stream, you don't instantiate an output stream directly. Instead, you work with its subclasses such as file output stream, buffer output stream, or data output stream, depending on your specific needs. Here are the main methods provided by output stream. Write writes the specified byte to the output stream. Wide flash forces any buffered output bytes to be written out. Closes the stream and releases system resources. The output stream class is essential for writing binary data, such as writing serialized object data, media files, or sending bytes over a network. In practice, you will often wrap an output stream with other streams for improved performance or functionality. For instance, using a buffered output stream to reduce the number of write operations or a data output stream to write Java primitives. Reader class. The reader class is the abstract superclass for reading character streams in Java. It handles the 16-bit Unicode characters, which makes it suitable for processing text files and internationalized content. As an abstract class, reader provides the basic methods required for character input and is extended by concrete classes such as file reader, buffer reader, and input stream reader. Key methods include it int read reads a single character and returns it as an integer. Wide close closes the stream to release resources. Boolean ready checks if the stream is ready to be read without blocking. Commonly used subclasses. Buffer reader adds buffering capability and introduces read line for line by line reading. Input stream reader bridges byte streams to character streams by converting bytes to characters using specified encoding. Understanding the reader class and its hierarchy allows for flexible text processing, especially when you combine it with other utilities like scanners, string builders, or patterns matchers. Writer class. The writer class is the abstract superclass for writing character streams in Java. It is a part of Java IO package and forms the base for all classes that handle textual output. As with reader, writer is designed to work with the 16-bit Unicode characters, making it ideal for writing readable text content to various destinations like files or console. Key methods of the writer class. Wide write int C writes a single character. Wide flush forces any buffered output to be written. Wide close closes the stream and frees resources. Important subclasses include buffer writer adds efficiency through buffering and introduce new line for writing line breaks. Print writer offers convenient methods like print, println, and printf similar to system.out. The writer class is essentially when you need to generate text reports, logs, configuration files, or any other human readable output. It ensures that characters are correctly encoded and written, saving you from manual byte handling. The file class. The file class in Java is part of the Java IO package and plays a crucial role in file and directory management. Unlike input and output stream classes, the file class does not read or write file content. Instead, it provides an abstraction to access file and directory properties such as path, size, existence, and permissions. You can create a file object using this line creates a reference to a file named example.txt, but it does not create the actual file in the file system. The file is only created when a stream writes to it or if you call file.create new file. Common methods of the file class include delete, deletes the file or directory. Mkdir creates a directory. Length returns the size of the file in bytes. Get name, get path, get absolute path, provides file path details. Is file is directory. Difference between a file and a directory. The file class is essential for validating file paths, checking existency before reading or writing, creating directories for output storage, and navigating file systems. Creating files in Java. Creating a file in Java is straightforward and is typically done using the files to the create new file method. This operation attempts to create a new empty file in the specified location. If the file already exists, the method returns a false. It's important to handle exceptions here because create new file throws an IO exception if an input and output error occurs. This could be due to permissions, invalid paths, or hardware issues. Additional points to keep in mind. If the path includes directories that don't exist, they must be created using mkdir or mkdir before file creation. You can also use file writer or file output stream to indirectly create a file when writing data to it. File permissions and access mode should be verified before performing operations. Creating files is often the first step in many file handling tasks such as logging, report generation, configuration saving, or user data storage. Once a file is successfully created, you can proceed to write content or append data using appropriate writer or output stream classes. Reading files. Reading files in byte mode is useful when dealing with binary files like images, videos, or any non textual content. In Java, this is achieved using the file input stream class, a subclass of input stream. Key points. Byte streams do not handle character encoding, suitable for all binary data formats. Must allow close this stream using close to free up system resources. It's also best practices to wrap the input and output operations inside a tray with resources block to ensure the stream closes automatically. Writing to files using byte streams is handled by the file output stream class in Java. This is ideal when you are dealing with binary data like images, video, or serialized objects. The file output stream class allows you to write data one byte or any array of bytes to a file. Best practices allows close the stream after writing to avoid resources leaks. Use buffering to improve write performance. Wrap the stream with data output stream if writing primitive data types like int, float, or double. For textual content, using byte streams requires manual conversion to bytes, which may be inefficient and errorful. For such cases, character streams like file writer are more suitable. Reading files. When working with text files, using character streams is much more convenient than byte streams because they handle character encoding automatically. The most common class for this purpose is file reader, a subclass of reader. Why use character streams? They handle multi-byte characters and different encodings. They are easier for developers to use when reading human readable content like configuration files, HTML, or plain text. Always remember closing the stream is essential to avoid resources leaks. Consider using try with resources to auto close. Writing files. When you need to write text to a file writer is the preferred class in Java. It simplifies the task of writing characters, strings of arrays of characters to a file without requiring manual encoding. Always close to flush the writer to ensure data is physically written to the file. If working with large volumes of text or writing frequently, prefer buffer streams. Character based file writing is very common in applications like loggers, configuration generators, or report writing tools. The built-in flexibility and ease of use make FileWriter and its variants indispensable in Java input and output. Buffered streams. Buffered streams are wrappers that enhance input and output efficiency by reducing the number of read and write operations directly to disk or other resources. Instead of reading or writing one byte or character at a time, buffer streams read and write larger blocks of data at once, storing them in memory buffer. For character streams, buffer reader wraps around reader adds the ability to read lines using readline. Buffer writer wraps around writer improves output efficiently and adds new line method. Why buffering matters? File systems are slow compared to memory. Without buffering, every read and write operation accesses this file system. Buffer streams accumulate data in memory and access the file system only when necessary, minimizing overhead. They help in performance critical applications, especially when handling large files or many small operations. Buffer streams should be used whenever input and output performance is a concern. They are particularly effective in loops, file copying, and real time applications. Buffer reader example. Let's explore a real world example of using buffer reader. One of the most efficient tools for reading text data line by line. It's commonly used in scenarios where you need to process structured text like logs, configuration files, or large documents. Advantages of buffer reader: much faster than reading character by character, makes parsing easier since you get one complete line at a time, reduces the CPU and disk usage, especially on large files. Always consider buffer reader when you are reading human readable files line by line. Buffered writer example. Just a buffer reader improves reading performance. Buffer writer enhance writing efficiency by buffering character output. It writes large chunks of data at once instead of writing character by character to the file system. Why use buffer writer? Faster performance due to reduced input and output operations. Supports writing multi-line structured data like reports, logs, or configuration files. Prevents resources leaks by ensuring buffered content is written only once in bulk. You can also use it with a try with resources for automatic closure. Buffer writer is especially useful when writing large files, writing content generated in loops, creating formatted output like CSV. Scanner class. The scanner class in Java found in the java.util package is a highly flexible tool for reading and parsing input from various sources, including files, strings, and the console. While it's often used for console input, it's also incredibly powerful for file reading. Why use scanner? It can parse primitive data types and strings using regular expressions. Provides methods like next int, next double, next, and next line for structured input. Automatically tokenizes the input, making it ideal for parsing CSV files or formatted data. Key methods: has next line, checks if more input exists. Next line reads the next token or line. Use delimiter allows custom splitting based on characters like comma, space, etc. Scanner simplifies reading and parsing structured text and is often used in file processing, user input collection, and text based applications. Print to writer class. The print to writer class is powerful and convenient way to write formatted text to a file or output stream in Java. It's part of the java.io package and builds on the writer class but adds user-friendly methods like print, println, and printf, very similar to system.out. Advantages: it supports auto-fleshing when used with constructors that accept a second boolean arguments. Excellent for writing logs, reports, tabular data, or formatted output like currency or percentages. Can wrap around file writer, buffer writer, or even system.out. It's also safe to use in a try with resources. Keep in mind, always close the writer to flush data to the file. It silently swallows input and output exceptions unless explicitly handled, so use carefully in error sensitive systems. Print writer is ideal when your output requires formatting multiple data types or line by line control. Now that we have covered writing, let's focus on exception handling during input and output operations. Exception handling in input and output. Exception handling is critical when performing input and output operations in Java because many things can go wrong. Files may not exist, you may lack permissions, or the storage device could fail. Java uses checked exceptions to force developers to handle such possibilities. Most input and output classes throw input and output exception or its subclasses. You must either catch those exceptions using try catch blocks or declare them with throws. Benefits of try with resources automatically closes this stream. Cleaner and more concise code. Common input and output exceptions. File not found exception, EOF exception, IO exception. Handling exceptions properly ensures your program remains stable and user friendly even when errors occur. Serialization overview. Serialization in Java is the process of converting an object into a byte stream so it can be written to a file sent over a network or stored in a database. Java provides this functionality through the serializable interface found in the java.io package. To make an object serializable, a class must implement the serializable interface, ensure all non-transit fields are serializable themselves. Advantages of serialization saves object states easily to file, useful for data persistency or transferring objects between systems. Important points transit keyword can be used to exclude fields from serialization. Serial version UID is used to ensure capabilities during deserialization. Serialization is a core part of enterprise systems where object persistence is required. Let's now understand how to reconstruct those objects using deserialization. Deserialization overview. Deserialization is the reverse of serialization. It converts a byte stream back into a Java object. This process reconstitutes the original object in memory, making it ready for use as if it had just been created. In Java, deserialization is done using object input stream, typically paired with file input stream. Points to remember. The class must be marked serializable for both serialization and deserialization to work. The class definition must be available at runtime. If the serial version UID does not match, a invalid class exception will be thrown. Why use deserialization? To load saved state, to transfer objects between applications or systems, to reduce expensive computation by storing pre-computed results. Important deserialization. Avoid deserializing data from untrusted sources. Deserialization is powerful in distributed applications. Thank you for your attention. I hope this session empowers you to build